In this video, I will help you understand a variety of technical education opportunities available at BYU, Idaho, with the hope that it will help you in deciding your course of study. Here is a quote from President Hinckley to set the stage. "The Lord wants you to educate your minds and hands, whatever your chosen field." We all know that some fields of work require more training of the mind, and some require more training of the hands. I like to think of technical education as being a continuum. Programs toward the left are more focused on training the mind, while programs toward the right are more focused on training the hands. Perhaps the word theory is a good word to use when thinking about training the mind, and developing skills is a good way to summarize what is meant by training the hands. Examples of programs that lie to the left in this area are physical sciences like physics, chemistry, or geology. Let's say for simplicity's sake that an average physics program contains about 80% theory-based training and about 20% practical skills kind of training. On the right, we find technology programs, which are much more focused on developing practical skills, perhaps only 20% theory and 80% skills. This area on the left side of center describes traditional engineering disciplines, where there is a significant amount of theory but definitely a strong focus on application, perhaps 60% theory and 40% application and skill-based training. That leaves a large gap in this area. Are there educational programs that fit in this area? Yes, there are. Perhaps these programs are not as well known by incoming freshmen, but they provide very marketable careers. Engineering technology programs are specifically designed to fill the needs of this area. These programs contain more hands-on training than traditional engineering programs, but still retain a decent amount of theory, perhaps 40% theory and 60% skill-based training. We often hear people refer to careers in this area as blue-collar or vocational employment, and careers in this area are often referred to as white-collar employment. Perhaps what is more important than what others call them is what they call themselves. Individuals with this type of training call themselves scientists. People with training in this area call themselves engineers. People with training in this area call themselves engineering technologists. And people with training in this area call themselves technicians. It might be helpful to discuss some generalities of what individuals who work in these areas do. Scientists are very interested in the process of discovery and are continually trying to better understand physical laws and phenomenon. Engineers are interested in applying this understanding in beneficial ways and are often involved in designing, analyzing, or optimizing. Technologists focus their efforts toward implementation. They often work with engineers and help facilitate testing and manufacturing. Technicians are involved in installation, maintenance, and operation of equipment and facilities. Another good way to gain insights into these disciplines is to understand the level of math required for entry-level positions. Technology programs usually only require basic math skills such as arithmetic, basic algebra, and geometry. Engineering technology programs go beyond basic math and require college algebra, trigonometry, and calculus. Engineering programs not only require basic math, college algebra, trigonometry, and calculus, but also require students to continue on and study multivariable calculus, linear algebra, and differential equations. Engineering programs also require a course in statistics. Physical science programs usually have very similar math requirements as engineering programs. Let me clarify these math requirements by showing course numbers associated with BYU, Idaho. Technology programs here usually only require the Foundation Math 108 class. The engineering technology programs require Math 109 called Pre-Calculus, which contains both college algebra and basic trigonometry, Math 112, which is basic calculus, and some of these programs may also require Math 330, which is a course in engineering statistics. The engineering programs at BYU, Idaho require Math 109 Pre-Calculus, Math 112 Basic Calculus, and Math 215 and 316, which cover the topics of multivariable calculus, linear algebra, and differential equations. Math 330 Engineering Statistics is also required. The physical science programs at BYU, Idaho have the same math requirement as engineering, except some of them may not require statistics. Now I would like to show you which degrees are available at BYU, Idaho in each of these areas. In the physical sciences area, we offer 4-year Bachelor of Science degrees in physics, chemistry, and geology. In the engineering area, we offer 4-year BS degrees in civil engineering, computer engineering, electrical engineering, and mechanical engineering. In the engineering technology area, we offer 4-year BS degrees in agricultural engineering technology, automotive engineering technology, manufacturing engineering technology, and welding engineering technology. In the technician area, We offer both applied associate degrees and bachelor degrees in agricultural technology, automotive technology, and welding technology. Now let's look at a few scenarios. What are your options at BYU, Idaho if you are really interested in the agricultural equipment industry? You could choose a bachelor degree in mechanical engineering, a bachelor degree in agricultural engineering technology, or either an applied associate degree or a bachelor degree in agricultural science and technology. I was recently on the CNH corporate website and looked at some of the job postings at Case New Holland. Design engineering positions were available and required a full engineering degree, such as mechanical engineering. People in these positions would be involved in designing new products and processes, as well as developing improvements to existing products. Test engineering positions were also available and were open to individuals with agricultural engineering technology degrees. People in these positions test and evaluate equipment in actual or simulated field conditions. They make recommendations for product improvements and work with design engineers to resolve product issues. At local CNH dealerships around the country, you can find job postings for agricultural equipment technicians who are directly involved with troubleshooting and repairing the equipment. Now let's look at your options if you are interested in the automotive industry. You could choose the BS degree in mechanical engineering, the BS degree in automotive engineering technology, or either the AAS or BS degrees in automotive technology. Here are some examples of employment opportunities with Ford. The Ford corporate career website recently listed an opening for a product development engineer with a transmission and driveline group. This individual would help with the design of shafts, differentials, planetary gear sets, and other transmission and driveline components. Ford and its contractors also hire service engineers and test engineers. Service engineers are responsible for evaluating the maintainability of product designs. They develop repair procedures and assist and train technicians. Test engineers are involved with the setup and testing of vehicles and components and work with the design engineers to resolve issues and recommend product improvements. At Ford dealerships around the country, you can find job postings for automotive technicians who are directly responsible for troubleshooting, diagnosing, and repairing vehicles in accordance with dealer and factory standards. What might be some of your options if you are interested in the aerospace industry? A BS degree in mechanical engineering is very marketable in the aerospace industry. A BS degree in manufacturing engineering technology is also very marketable in the aerospace industry, as is an applied associate degree as a manufacturing technician. I was recently on the Boeing website and noticed a job posting for a design engineer. This person would be responsible for designing structural aircraft components, developing technical specifications, and reviewing supplier capabilities for sourcing those components. I also noticed a job posting for a manufacturing engineering technologist. This person would be responsible for applying automation and robotics on the production line of advanced aircraft. I also noticed a job posting for a manufacturing composites technician who would be responsible for performing repair procedures on carbon fiber composite components. Now let's look at your options if you are interested in the welding industry. You could choose a BS degree in mechanical engineering, a BS degree in welding engineering technology, or either an AAS or BS degree in welding technology. A mechanical engineer would be involved in designing industrial machinery to meet customer needs. A weld engineering technologist would teach and program welding robots, develop welding fixtures and tooling, and design and inspect welds to assure function and reliability. A welding technician could be involved with the fabrication and welding of industrial machinery to design specifications. I hope you are noticing that each of these areas is pretty broad and can accommodate a variety of interests. One physicist may be focused on discovering and formulating underlying theories, while another may be more interested in application, modeling, and simulation. I know engineers who really enjoy developing computer tools to simulate complex systems to facilitate design optimization. I know other engineers who prefer to be out in the factory designing and implementing manufacturing tooling. It's not uncommon to see one engineering technologist involved in testing, instrumentation, and validation, and to see another technologist installing or repairing high-tech equipment. Technicians can be equally as diverse. Some prefer to be helping develop new advanced welding processes, while others are true craftsmen. It's also important to see that these areas have significant overlap. Perhaps your interests are in this area. You could find satisfaction as a physics major or an engineering major. What if your interests lie here? You could be successful as an engineer or an engineering technologist. What if this is you? You could be happy as a technologist or a technician. I would advise you to give some thought to where your interests and aptitude lie. I feel like this is where I fit. I love the math and science involved in design and innovation, and I love being involved in fabrication and prototyping as well. Mechanical engineering was an obvious choice for me and is turning out to be a very satisfying career. Here is a summary sheet of the marvelous educational choices we have discussed in this video. Each one could lead to a secure and honorable career. I recognize that choosing a college major is a challenging decision, and hope that the information on this sheet is helpful to you. As I have observed hundreds of incoming freshmen wrestle with this choice, I have noticed a few mindsets that get in the way of making a wise choice. First, I noticed that some people let pride cloud their judgment. The desire for prestige is a prideful motive. Don't turn your back on a career that fits your interests and aptitudes simply because it doesn't have a prestigious title. The honor and glory of the world does not bring joy and satisfaction. In other words, don't choose a major so that people will ooh and ah when you tell them what you are studying. Greed is also a prideful motive. Don't choose a major to get rich. While the Lord wants us to be financially self-reliant and to be good providers for our families, He does not want us to make the detrimental mistake of focusing our time and effort in the pursuit of luxury and ease. The second mindset that often clouds people's judgment is the desire to know the end from the beginning. This displays a lack of faith in the Lord's guiding hand. Hymn number 97, titled "Lead Kindly Light," includes this phrase, "I do not ask to see the distant scene, one step enough for me." Too many freshmen are so worried about making the wrong decision that they end up making no decision at all. Trust what the Holy Ghost tells you in your mind and heart, and move forward in faith. The Lord will reveal additional details about future decisions as you need them. Here is the summary sheet again. Pray for the Lord's guidance in this important choice. Live worthy of the Holy Ghost and do your part by working hard and acting in faith. The Lord will help you discover the next step you should take. May each one of you find joy and satisfaction in your profession as you help your family become financially self-reliant.